Okay, so today we're going to look at section 17.3, rates of flow. So sometimes we're talking about liquid flowing from one container to another, or from a pipe into a container. And what we really are talking about is what's happening in either a second or a minute. So how much is passing through that pipe or container in a second or a minute. So it depends what units. Just keep a close eye on units so that they're not mixing up units within the question, because you'll need all the units in the same thing. Alright, so it's the volume of that cylinder or other container in 1 second or 1 minute is what we're really talking about. So the easiest way to explain it is just to do some examples. So I'm going to do question 1 in exercise 17.3. So water drops into a graduated cylinder. That just means it has a measurement on it. You should know that from science, I think, of a diameter 10 centimeters. So the diameter of the cylinder is 10 centimeters. That means my radius is 5. At a rate of 20 centimeters cubed per minute. So that's telling you for each minute 20 centimeters cubed is going in there. Alright. How high will the level have risen to in 10 minutes? Okay. So we're talking about a volume of a cylinder, but we want to know what height will it get to on the cylinder in 10 minutes. Now it's telling you that 20 centimeters cubed is going in per minute and it's over 10 minutes. So the first thing you're going to do is multiply 20 by 10, and that will tell you how much has gone into the container in the 10 minutes. Okay, so now we're going to do volume of a cylinder formula, which is pi r squared h. The volume of the cylinder is 200 centimeters cubed. It's not the volume of the whole cylinder, it's the volume of water in the cylinder. Okay, but that itself is a cylinder shape as well. Okay, so pi, in this exercise they told us use 3.14 for all questions. R is 5 and h is what I'm looking for. We want to know how high the level of water in the cylinder will be. So again, we want to keep h on its own. So keep h at this side, bring everything to the other side. These two things are being multiplied by h. When I bring something over the equal sign, I divide, because dividing is the opposite of multiplying. So 200 over 3.14 and 5 squared. Into your calculator, and you get 2.547 centimeters, okay, for your height. Now it didn't say to any number of decimal places. If it did, just make sure you give it to a certain number of decimal places. Okay, next example then. An overflow tank with dimensions 80, 60 by 60 has water pouring into it at a rate of 20 litres per minute. How long does it take the tank to fill? And it tells you that 1 litre equals 1000 centimeters cubed. So this is my tank. Okay, so 20 litres. So if you notice here, this is given in centimeters. So let's change everything to be the same. So I'm going to change my 20 litres to centimeters. So to do that, each litre is 1000 centimeters cubed. So multiply 20 by 1000 to get my answer in centimeters cubed. So 20,000 centimeters cubed. That's the rate water is pouring in at a rate of that per minute. Okay, so then the volume of my tank, sorry, just make this up, is 80 by 60 by 60, which is 288,000 centimeters cubed. So how long will it take the tank to fill? So this is the full tank. This is what's happening per minute. So if we divide this by this, we'll find out how many minutes it takes to fill the tank. So 288,000 divided by 20,000 into your calculator, you get 14.4, and that's 14.4 minutes. Okay. Alright. So it's just, there's a lot of words in these questions, but it's just a matter of looking at what they've given you and how that helps you. Okay, and breaking down the question. Okay, so we're just going to do one more question, 7. Finn said it took 1 minute and 20 seconds for a sink of water to empty completely. The radius of the hemispherical sink was 18 centimeters. The radius of the water pipe was 3 centimeters. Okay, so this is my sink. It's full up to the top. This is my cylindrical pipe coming out. This is a hemisphere, so this is half a circle. Alright. And then this is my pipe, which is a cylinder. So the first part says the volume of water in the sink. So the sink was full. So we're doing volume of a hemisphere. So remember, in your logbooks, they don't give you volume of a hemisphere, they give you volume of a sphere. So write down your volume of a sphere and you're dividing by 2 because hemisphere is half it. Okay, then you're just filling it in. Pi, again in this example, they've told us to use 3.14 the whole time. And they've told us that the radius of the sink was 18, so R is 18. All over 2 into your calculator, and you get 12,208.32 centimeters cubed. Okay, so that's the amount of water that was in the sink when we started. Okay, part 2, the volume of water passing into the waste pipe per second. Okay, so they told us that it took 1 minute 20 seconds for the sink to empty. So let's change that all to seconds because they're talking about seconds. So 1 minute 20 seconds. So 1 minute is 60 seconds. So 60 plus 20 is 80 seconds. Okay. Now, my sink was full when it had this much in it. And it took this long to empty it. And I want to know the volume of water passing into the waste pipe per second. So if we divide this by this, that will tell us how much was going into the waste pipe per second. So my volume over 80 into your calculator, and you get 152.604 centimeters cubed per second. Okay. And then the last part of the question, it says the rate at which the water is passing through the pipe in centimeters per second. Sorry, that's a bit hard to read. So the rate at which it's passing into through the pipe. So the rate is always just our snapshot of that shape in 1 second. So here we're talking about a cylinder shape. So we're going to talk about volume of a cylinder, and this is what's happening per second. So volume which is pi r squared h, and that's going to be equal to this over here. Let me just get rid of that line. I've ruined, sorry. Okay, so again we're going to fill it in. We know pi is 3.14. We know the radius of the cylinder is 3. We're looking for h because that's our snapshot of 1 second. Okay, again, whenever we're looking for a letter on its own, bring everything to the other side and do the opposite of what it's doing at the moment. So all of these go under the line. So h is, when you stick it into your calculator, is 5.4 centimeters per second. Alright. So that's quite a difficult thing to get your head around. But try and understand what the question is asking. So the questions I've set are kind of based on the examples I've done. So give them a go. And I can do more if you feel you need them. Just give me a shout. Okay, so exercise 17.3, try question 3, 4, 5, 8 and 9. Okay.